Hello, welcome to today's daily Leetcode challenge in Rust. Today I'll be solving question 706, Design HashMap. If you're looking for the thorough explanation on how to solve this, please check out my Python video that I've linked here. With that, let's begin the Rust implementation. As I mentioned before, the implementation for a hash map under the hood uses an array and a function called hash. For the purpose of this question though, since the key is always a number, we're going to be, or an integer really, we'll be using the number modulo the size of the array itself to emulate the hash, to emulate doing hash function on the key. With that, let's begin the question. So we are going to need a size of type U size. This is the Rust standard for sizes, array sizes. Then we're also going to need the array itself. It's going to be a vector, which in itself is going to be a vector of tuples I32 to I32. So this essentially looks like a 2D array with values of type tuples, key value being both I32. Let's implement the constructor or the new method that's going to return ourselves. I'm going to let size equal a specific number. We're going to be changing this potentially in the future. And my hash map with size equaling size and the array equaling a vector, which in itself has a vector of empty elements, but this is of size. Perfect, and we're returning this as well. Cool. So now for the put, this method would include or add a key value pair into the hash map. We're going to say that index is going to be the key modulo self size. This is the key of the value where we're putting it, but as you know, the value itself doesn't live specifically in one point. It lives somewhere in this nested vector, which has these key value pairs. All that we know at this point is in which of those nested vectors it lives. And so what now we have to do is, let's call it inner index, because it's going to be telling us where the actual value that we need to, or where at which point do we actually need to insert the key value pair in the case where the key value pair already exists. And now for I in and sorry, this is not going to be in range, in self r indx of the iter mut, we need to borrow the mutable reference to we need to borrow the mutable reference to the inner array, because we're going to be modifying it potentially. I'm also calling iter mut and then enumerate, because I also want to conveniently know at which index the value that I need to modify exists. Now that I have the for loop set up, I want to actually find this value, and I'm going to say that if, and I'm going to destruct k, which is my key value is equal to key. If this is equal to key, then inner indx is equal to I. And that lets us, at the end of the day, match the inner index to either sum of I, which will then say that, oops, if we find it to be sum, then we simply set the index of some specific inner indx to this new value, key value. And in the case where it's not sum and it's actually none, we would simply self r at indx, we would push the key value pair. And that concludes our put. We don't have to return anything here, so simply putting it in the case where the key and the value already exists in the nested array, or just simply appending that new key value pair to the innermost array at index, will do. The next function we need to implement is get. So get follows the same principle. We need to first find the array or the vector that the value will reside in or potentially resides in, and for key and value in self r indx. I actually need this to be a. So we borrow the reference to the innermost array with this at, meaning the address of the innermost array, key value pair. And here we say that if k is equal to key, if at any point this happens, then we return the value, or better yet, the destructured version of the value, and return, otherwise -1. -1 as said here, get or -1 if it's not there. I also forgot to mention that since we are modifying the arrays, the innermost array in the put and the remove, we have to modify the type that we're actually getting, and that is the mut self. We're modifying the mut self, and it says here that you're able to do this. Change it to mut instead of, if you need a mutable reference, and we do need a mutable reference. Cool. So that gives us the put and the get. Finally, let's think about the remove. The remove here will also follow the same structure where we first find the index of the innermost array that holds values that are hashed to that specific key, and then for I, k, for in self r indx iter mut, because we need to and enumerate, we're going to want to say if destructured version of k is equal to key, as we did before pretty much everywhere else. We're going to say self r at specific index, remove the I, and break. So this is the quickest function to implement because we simply check if there is a element or a key that matches exactly the key that we set. And if it does, simply remove it and get out of the function. So this should work. Let's see if I made some syntax mistakes somewhere. And I definitely did. Cool. So I might have mistook what the size has to be. No, the size is correct. So self size is always equal to U30 U size. And yes, I just realized that I would have to cast them here, and I would also have to cast them pretty much, well, everywhere where I'm doing any sort of computation, because in Rust, when you're doing a computation, it has to be on the same value type. And uSize is now correct. So inner indx, does this have to be sum break also? If we find it, we get I, which is just a regular U size equal to sum, which is, I believe, an option enum of, or an enum of a type of enum for option, and then we match it to sum or none. Let's see, do I have to do this anywhere else? I don't think so. Cannot be indexed by, okay, so if it cannot be indexed by, what does that even mean? Oh, if I'm finding what inner index is matched with, if it's matched with some I have to use that I can't just, and here as well, if I is not matched, then I would just use the indx, which is the innermost, right? Cool. Slowly but surely. Okay, so here it's asking me if cannot assign twice to an immutable inner indx. And so did I not set this to mut? I didn't set this to mut, to mutable. Awesome. And in the real world, a type checker would easily catch these mistakes, but we're not there yet, so this is what we have to deal with. And perfect, we beat about almost 100% of the submissions. With that, this is my second video for the Rust channel, so hope this helps. See you later. Bye.